Hi guys, if you're listening to this, it's because you can't make it to class because you're taking all your AP tests. So I'm going to give you the notes on partial fractions. I think you'll find it's not hard at all. But first of all, here's Buddy, and he wants to say he's sorry about snoring this time. And he has a little message for you because today's his birthday. And I locked him outside of my room so he wouldn't make noises. So he just wanted to say hi. So there he is. He's 10 today. Okay, so let's go. And I handed out this partial fraction note sheet, and I also put it on my website. So if you didn't get it, you could always print it out from my website. So I'm going to start giving you the notes on partial fractions. Partial fractions you will see again in calculus. When you go to do an integration, and you'll learn what that is, you want to take apart a fraction because it's easier to work with. So what we're going to do, I'm actually going to start with number 2 on your note sheet. So I'm just going to kind of move this and make this a little bigger. And we're going to start with problem number 2. So the first thing we want to do is factor the denominator. You're factoring again, and they're all sometimes they're even factored already, and they're very easy factoring. So when we go to factor x squared minus x minus 2, that color's not good. That's going to give us x minus 2 times x plus 1, and that's what that trinomial factors into. So what we want to do is actually separate this apart. So let me erase this bar up here. I don't really want that. What we want to do is separate this apart and find out what 2 fractions did we use to add together to get this as our answer. So what you do is you spread apart, you factor, and you take each factor becomes a new denominator, and you put like an A and a B, on top of each of your factors. And if you had a third factor, you'd put a C. Okay, so now you have to kind of go through the processes. Oh, if I was going to get a common denominator, what would I do? So you would have to multiply, you would have to multiply this fraction here by x plus 1, this fraction here by x plus 1, and this fraction, the second fraction, by an x minus 2. So it would look something like this. Oh, common denominator would be x minus 2 times x plus 1. So I would have to multiply the a times the x plus 1, and I would have to multiply the b times the x minus 2. Okay, does that make sense to everybody? Like if we didn't know what the answer was, that's what we would do to get a common denominator. Now, you really don't need the denominator anymore. So we're not going to even worry about it, but we're going to work with the numerator. I hope that you see that the numerator here has to be equal to this numerator. So I'm using yellow, that doesn't show up so good. So what I'm going to do is I'm going to say, oh, a times x plus 1 plus b times x minus 2, really, when you come down to it, has to be equal to a negative 5x plus 4. So that's what we're going to be working with. So you have to get the common denominator to find what you have to multiply the tops by, but once you do that, you don't need the denominator anymore. So the next thing we're going to do is distribute all this stuff. So this is going to be ax plus a plus bx minus 2b, and that's all going to be equal to negative 5x plus 4. I'm going to change this color. I'm going to make it red. Okay. All right. So the next thing you do is say, okay, what on the left side would be the coefficient of the linear term? Oh, so it's everything that's with an x. So this and this would have to be equal to the negative 5x. So we don't really need the x's. So what I'm going to do is write, oh, that a plus b eventually would have to be equal to the negative 5. And then we're done with that. So the rest of the stuff would have to be equal to the 4. So then I'm going to say A minus 2B has to be equal to 4. And then you see that we have a systems of equations. And that's why we do this in the matrix section, because sometimes you can use your little RREF trick to solve for the systems of equations. Well, this one's pretty easy. So if we take and subtract the bottom equation from the top equation, which changes the signs, and we add that together. I'm actually going to put that over there. If we add those two equations together after I change the bottom sign, the A's will cancel out. So that's going to leave us with 3B is equal to a negative 9. So B is going to be equal to a negative 3. Oh, if B is equal to a negative 3, then it's really easy to see that A would have to be equal to negative 2. Because a negative 2 and a negative 3 would have to equal a negative 5. Oh, so that's our answer. I know now we go back to the very first thing that we wrote, and we would say the answer is negative 2 over x minus 2 minus 3, because it's a negative 3, otherwise we put a plus, all over x plus 1. If you added these together, this is a minus, if you added these together, would give you this up here, okay, if you went through the whole thing. So in calculus, it's easier to work with this kind of expression than it is this kind of expression. So that's why that's eventually where you're going to use partial fractions, is to take apart a rational expression. Okay, does that make sense? All right, so now let's try, let's go back to number 1, and let's see what happens when we have that sort of a situation. Oops, sorry. I'm going to try to make this bigger so I have more room. Okay, so let's look at number 1. So first thing, what are we going to do is factor. Oh, but what does this factor into? This factors into x plus 1, the quantity squared. So, oh, now what do I do? Well, and then the numerator would be this. Well, when you have a quantity squared, you have to take it apart. You have to say one of the denominators could have been an x plus 1, and another denominator could have been an x plus 1 squared. So if you do have a quantity squared, you have to write it linear, and then you have to write it quadratic. If you had a cubic, then you'd have to do a linear, a squared, and a cubic. So that's the next kind of problem. So I'm trying to do each type of thing that could happen. All right, so what are we going to do? We're going to put an A here, and we're going to put a B here. You always put A and B if your x's in your binomials are linear. Okay, so what do we have to multiply? We'd have to multiply this by an x, another x plus 1 to get a common denominator. So what does this look like? It looks like A times x plus 1 plus B would have to be equal to 6x plus 4. And notice, now this time I'm not bothering with the denominators because I don't really need them anymore. I needed them so I could find what I have to multiply the top stuff by. Okay, so now let's distribute. So this would give us ax plus a plus b is equal to 6x plus 4. So this is a really easy one. We know that this would have to be equal to 6x, so a has to be equal to 6, and so a plus b, the leftover stuff, would have to be equal to 4. But if a is 6, then b would have to be equal to negative 2, because if 6 minus 2 is equal to 4. So how would we write our final answer? We would say that, what's our A? 6? Let me make that black. So our final answer would be 6 over x plus 1, and then b is equal to 2. So again, I'm going to have, you could put a minus here, Or you could put a plus, but then make your 2 in the numerator negative. It doesn't really matter how you write that, how you do your negative. And that would be your squared. So that would be your answer. So if you added these two fractions together, you would end up with this. Okay? So hopefully you're getting the hang of this. And you can kind of skip. I'm skipping some steps, so hopefully you're following along with me. All right, let's do another type. Let's go to number 3. Okay, so number 3, let's see if I can make this a little bigger. Okay. And my pen. Okay, so number 3, notice it's got an x squared in the denominator. So when the x in the denominator is quadratic, what you have to put in the numerator is linear. It's always got to be 1 degree. The numerator has to be 1 degree less than what the denominator is. So this is already factored. You can't do anything more with this. So what this looks like is in the numerator, you have to put ax plus b. That's your standard form for a linear equation, all over x squared plus 1. Because this was x squared, you have to have a linear in the numerator. Okay. And then we can say plus, and then the other factor was x minus 2. So the numerator here, since this is linear, we could just put a c. You just keep going along the alphabet. Okay, so now we have to get, what would you have to do to get a common denominator? This is the easy part. So in this numerator, we would have to multiply by x minus 2, and in this numerator, we have to multiply by x squared plus 1 to get x squared plus 1 times x minus 2. Okay, so if we do that, I'm going to write out the next line. I'm going to multiply ahead of time. I'm going to multiply while I'm writing it out. So I'm going to take this right here and I'm going to multiply. So that would be ax squared minus 2ax plus bx minus 2b. I'm trying really hard not to make a mistake. So this would be plus cx squared plus c. And what does all that have to be equal to? Negative 7x squared minus 4x minus 14. Okay? So hopefully you're following along and this is making sense. So the next thing we have to do now is gather all this stuff that would be the coefficient of an x squared. So there's only, there's 2x squareds. Here's an x squared and here's an x squared. Okay? So we're not going to write the x squareds, but we're going to say that a plus c has to be equal to negative 7. Okay, then I'm done with those babies. The next thing I'm going to do is find all my linear coefficients. So my linear coefficients would be the 2ax and the bx. So that's going to give me a negative 2a plus b, and that would have to be equal to a negative 4. And then the last stuff is just the constant stuff. So I'm going to have to say what's left. So I got a negative 2b plus c would have to be equal to a negative 14. Okay, so hopefully that makes sense to everybody. Okay, now this looks, you could solve this by subtracting and all that, but let's use what we just learned. Let's rewrite this as an augmented matrix. So if we write this as an augmented matrix, I think we could say it would be 1, 0, 1, negative 7, negative 2, 1, 0, negative 4, 0, negative 2, 1, negative 14. Okay? So there's my matrix. Okay, let me just double check because I wrote this out before. Okay, so now you guys, if you put this in your calculator under the reduced row echelon form, it would show you that A is equal to 3, and that B is equal to 2, and that C is equal to negative 10. So here's where you could use your what we learned in matrices to solve that system, and makes it easy and fast and kind of fun. So how do we write our answer? Let me see if I have a little room underneath here. Oh, I do. How would I write my answer? Since I know that A is a negative 3, I'm going to put, it's going to look like, Oh, okay. Oops, sorry. I thought I couldn't keep recording. I think I said -3. It's actually a is equal to +3. Because my writing is messy here. Pen. Okay, this is equal to 3. Okay, so since a is equal to 3, let me move this down just a smidge. I am going to put it back into my this original thing that I wrote, so that would become 3x plus 2, okay, because b is equal to 2 all over x squared plus 1, plus c was a -10, so that's -10 all over x minus 2. And so those would be the two fractions you would have to add together to end up with what our original problem was. And we're done. So that's basically how you do partial fractions. So now I'm just going to go to the third page. So you can try, hold on a sec, you can try to do 4. And sometimes the more on top you have, the more fun it is to do. So remember, when you go to set your, let me help you set the bottom up. So the bottom is basically already factored. So what do you need? You need an x squared plus 5 plus an x squared plus 5 squared, right? Because when the outside is squared, you need to have 2 of them. Now, when the inside is squared, you need an ax plus b, because you need a linear, and here you would use a cx plus d. And then you would get your common denominator. So you would have to multiply this term by another x squared plus 5, and then do your little foiling and set it equal. So see if you can do that one by yourself. Okay? All right, good. And now the next is all they want you to do. You don't have to solve it. All they want you to do is just set it up. What would it look like? So what would, you know, like how if you look at this example here, see how there's an x squared plus 7. So they have 2 of them. They had to put a linear on top. And then the extra one over here was x minus 2. Then stop. You don't have to go and do it. There's a couple like this on the test where you just have to set it up. So you could try those. And see how, you know, see if you, these are actually kind of fun. Now, if you want, I can show you how to do how to do number 5, because if the numerator is bigger degree than the denominator, you do have to do long division. You have to divide the x squared minus 1 into the top and then use the remainder to do the problem. So don't worry about this one. I could show you that in class. But the rest of them, I think you should be able to set them up. So the third page you're going to set up, but the other pages you're going to, you know, number 4 you want to finish and see if you can do it. I hope this helped. And I'm going to miss seeing you. I can't believe that next week is like the end of having my seniors. I just enjoyed you so much. I just love you guys so much. So I'm hoping for a good grade on this last test, and I hope this helps you a lot. Okay, and Buddy says goodbye too, and he's making noises outside the door, but I don't think you can hear it, hopefully. Okay, guys, I'll see you soon. Bye.